Assalamualaikum and good morning. Can you hear me?
Yes, betul.
Waalaikumsalam, Prof. Can hear.
Yeah. Okay, we move to the final subchapter of chapter 4, lead compensation or lead compensator. I'm referring to slide number 64. Okay, so lead compensator is the third compensator in frequency domain. The first one is the gain adjustment, then lag compensator, lead compensator, which the specific function is used to improve the transient response. Okay, so become faster lah. And this is equivalent to the PD controller in time domain. So with the board diagram, lead compensator will increase the phase margin and reduce the overshoot percentage. Okay, so increase of the gain crossover frequency and bandwidth to realize a faster transient response. Okay, gain crossover frequency, which is the and mega bandwidth. So the transfer functions of the lead compensator is shown here. Okay, where you have a gain, the ZC, and the PC. This form is quite hard to imagine, so we simplified into this form, where you have a S over ZC plus 1 and S over PC plus 1. Okay, so ZC is the zeros of the compensator and PC is the poles of the compensator. Please remember, for lead compensator, ZC is less than PC. Okay, compared to lag compensator, ZC greater than PC. But for lead, ZC less than PC. Okay, and beta is the ratio between the ZC over PC, which is less than 1. Okay. So the response of the lead compensator is shown here, where you have a 3 graph. This graph is okay, where ZC is the break frequency. And then this one. Okay, where PC is the break frequency. So the combinations, the total between the first one and the second one will be the bull color. Okay, bull response. Okay. And the phase as well, same as the phase as well. So you have a 3 response here. One is this one. This one is okay, where PC is the break frequency and ZC is the break frequency. For ZC is correspond to plus 45 degrees, and for PC is correspond to minus 45 degrees. And the total is here between 1 and 2. So the bold one is the frequency response for the lead compensations. So the uncompensated system has a small phase margin, uncompensated, and low phase margin at the frequency A frequency, and B is the phase margin. So using the lead compensator, the gain crossover frequency is to increase from A to C. Okay. So this yield a larger phase margin, D, a higher phase margin frequency, C, and a larger bandwidth, okay, at minus 3 decibels in the closed loop. So since beta is the ratio between ZC over PC, which is less than 1, so it has variations between the gain curve and the phase curve, okay, 0.1, 0.2, until okay, and then the beta, also the phase curve varying from 0.1 and 0.5. So the peak and the phase curve vary in the maximum angle. So there is a maximum angle, okay, at the frequency where the maximum occurs. There is a minimum and maximum. So you must operate between in that particular range. Very important frequency for lead compensator is shown here. Okay, you have a maximum phase angle, okay, which is omega max equal to ZC divided by beta. So ZC is the value of the zeros. Beta is the ratio between ZC over PC. Okay, the maximum phase angles is this one is getting from the is the formula. Once you get the beta, you can calculate the maximums. But if you don't have beta, so you get it from the booklet given. And then the compensator magnitude, okay, also from the booklet. So in lead compensator, booklet is given, okay, but you just get the value of the phase margin and gain margin before compensations, and then find the maximum angle, phase angle, and magnitude at omega max. So you don't have to draw like minus 20 dB line like lag compensator. Okay, just to get value from there. Most of the solutions is using the three formula, which is shown here. So lead compensator considered very easy compared to the lag compensator, because the formula is given, we just use it and get the values of the parameters and variables from the board plot given. So steps to design. First is you have to obtain the value of K, which satisfy the steady state error. And in order to find the K, so you have to identify the system is type 0, 1, or 2, KA, KP, or KV, and then you get the value of the whole gain system. And plot, and understand, not plot. Okay, because plot is given, understand the corresponding board plot. Like the test last week. So find the phase margin of the uncompensated system, phase margin. When gain curve, cut 0 decimal. Then calculate the additional phase needed by the lead compensator so that it satisfies the system requirement. For example, correction factor 10 degree. Okay. Then calculate the B needed, which is ZC over PC. Then calculate the compensator magnitude to obtain the beta above. Okay. Then obtain the new gain crossover frequency subject to the magnitude of the compensated system, which is equal but negative. Equal but negative to that of the compensators systems. Okay. And calculate for ZC and PC. Equal but negative. So draw the board plot, or this one is more towards verification and validations. Either whether the spec design has been fulfilled or not. If not fulfilled, just repeat the design. Okay, dia adalah dia punya algorithm dia or flowchart dia. Okay. Example 5. Amjad Tariq. Amjad Tariq.
Yes, doctor.
Read the question. Ikra.
Okay. Given the system below, use both diagram to design a lead compensator to a 20% overshoot and KV equal to 40 with a peak time of 0.1 second.
20% overshoot. Okay. So from 20% overshoot, we will get zeta using graph, and we will get phase margin. Definitely. Okay. And KV. KV is 40, meaning that system is type 1. Steady state 1 over KV. With the peak time 0.1 second. So we are using the same block diagram as in gain adjustment, as in lag compensator, and as in lead compensator, so that you can differentiate the difference between the gain, the lag compensator, and the lead compensator. So what is the open loop transfer function here? Shahir Ridwan?
100K over S, S plus 30C, S plus 100.
Okay, thank you. And again, you will use a formula. Okay, so we have 3 formula here. But if I am you, I will not use the formula. I will use the graph. Okay. So
Doctor, can I ask about the formula and the graph? Which is more accurate between two this?
of course, formula is more accurate, but if you want to work fast, you use standard graph, but you must have a ruler. Okay. You have a ruler, Shahir.
Yes, doctor.
20% overshoot. Shahir, tolong saya.
Uh, around 0.45 DP ratio. Around 48.
Okay, so in less than 15 seconds, we can get the answer. Okay, right. So for KV is equal to 40, K is equal to 1440. Okay. So the book, how you get 1440, okay, is from here. This one settled already. Okay. This one, KV is equal to 40. So use the formula SGS. This one is the open loop transfer functions with K value. Okay. So okay, cancel, cancel. So what is the value of K? Shahin, Shahin.
Yes, bro.
K,
114. 144.
1,
40.
1440. This one, eh? Okay, then workload is given. So first thing first, use your ruler. Targeted 0 decibel. Make a dotted line. What is the omega PM? Ahmad Najwan,
Yes, doctor.
omega PM.
30. 30 radian per second.
30, eh? Okay. 10, 30. So what is the value of phase margin? Fikri.
Afraid I don't know.
I'm afraid I don't know. Astaghfirullahalazim. Sharif.
Yes, bro. 60 degree.
How you get that?
What is that?
Phase margin.
Uh-huh. 60 lah.
Fokus Oh, ya jauh kat sebelah ni, tak fokus. Nur Hazika. Phase margin bah. Tak datang.
Negative 145.
Lambat bah. Delay Berapa? Degree,
55.
Okay. 55 degrees. This one? Azika? Omega GM?
60 radian per second.
Goes 60. So berapa gain margin ni? Tahu dia betul. Okay. Okay, 34 darjah Tadi kita dapat berapa? Just now we get it 35 degrees. Okay. From the slide is 34 degrees. Okay lah. Okay. 29.6. 29.6 tadi kita dapat 30 degrees. Okay. Okay. So therefore, the required phase margin from the lead compensator is 48.1, which we get from the graph targeted tadi. It's targeted kan this one. This one 48 from the spec from the given OS lah. Yeah. From the given OS 20% overshoot. Okay. Minus 34. 34 is the phase margin before compensation. Okay, the one that we get is 35. Okay, so dalam solution is 34. Okay, right? Plus 10. What is 10? What is 10 degree? Denson? Correction factor. Okay, so 48 minus 34 plus 10, so about 24.1 degrees. So that is the required phase margin. Okay, the one that based on overshoot minus the phase margin before compensation plus the correction factor. So targeted is 24 degrees. And this 24 degrees, okay, actually is at 37.1. Okay. So I have to clean up this one first. Okay. So 24 degrees phase margin. So phase curve at where? 180 minus 24. Berapa?
156.
156. Okay, meaning that 156 is, this is 150, 160 middle lah. Okay, somewhere there. So this is 10, 20, and this one is 37.1. Okay, the new phase margin. Okay. So this is the simulations, okay, to confirm all the values. So we start to, sorry, to calculate. So we start this one first. Okay, the maximum phase margin, which is 24.1. Yang kita dapat tadi itu. Where you get 24? 48 minus 34 plus 10. Inverse sine 1 minus beta over 1 plus beta. So we rearrange the formula. Sine 24 0.408 1 minus beta over 1 plus beta. So beta is 0.42, which is equal to ZC over BC. Okay. So beta dah dapat, goes to here. Step 2. Magnitude. This is a magnitude. Magnitude of the compensator at phase margin maximums, which is 1 over square root beta, 1.543. So 20 log 1.543, which is 3.76. So in the gain curve, kita negatifkan dia 3.76 supaya kita dapat the omega max. So, kita pergi dekat sini. This is 0. Okay. So 0. But somewhere here. Okay, what is the value of the frequency here? More or less 39 radian per second. So it is at 39 radian per second, okay, which is the omega max, and it will goes to here. Okay, step number 3. Omega max equal to ZC divided by square root beta, 39.6 or 39. So ZC will become 25.66. Okay, ZC 25.66, and then from there kita dapat beta, sorry, PC beta 0.42. So berapa PC-nya? Faris Haikal.
Ya, dah.
PC. Please help. $61.1. Okay. Dengan menggunakan these 3 formulas. So we just use the Bob law to get the gain margin and phase margin before compensations, and then we get the targeted phase margin and the frequency, and then get the omega max and the magnitude. Okay. So we get here 24.1, beta 0.42, 3.76, at omega max 39 radian per second. Okay. So to select as the new phase margin frequency, the frequency omega max at which the uncompensated system magnitude is minus 3.76 dB. From the Bode diagram, omega max is equal to 39 radian per second, as I showed you before. So ZC 25.3 PC divided, so you get 60. So now it fulfill this one. Okay, ZC is 25.3. This one is 60. Then the ratio is less than 1. So you put it inside here. And then this is the gain, which is PC divided by ZC, which produce 2.38. Okay, then this one multiplied with the open loop transfer function all together, then you can get the requirement, okay, by the boat plot. The phase margin is about 45.5 degrees. Okay, 45.5 degrees. Targeted is at 48 degrees for 20% overshoot. Okay. So it fulfilled. Any questions? Ada soalan? Soal Hong?
Yes, doctor. Hello. Yes, doctor.
Doktor, apa beza lead dengan lag, doktor?
Lead is to improve transient response. Lag is to improve steady state error. So in terms of solutions, so lead compensator, we use the boat plot given just to get the 3 values that I mentioned, which is the phase margin maximums, magnitude maximums, and the frequency maximums. Okay, once you get the value, you insert inside the formula, so everything is ready. Okay, for the lead compensator. But for lag compensator, you have to use the boat plot given, take out from the questions, and you have to show the solutions and the lag compensator magnitude on that particular draft. Okay, ada soalan?
Excuse me, doctor.
Yeah.
For the previous question, TS, what's the use of like the question giving us TS?
Yeah, we are not using that one. Okay. But I believe that is for the validations. After you get this, okay, this one, okay, find the closed loop and see the time response. Okay, so the one that mentioned is 0.1 second. Okay.
Oh, yes, doctor.
The one that mentioned the question is 0.1 second.
Yes.
0.1 second. So the one that we will get is much less than 0.1 second, meaning that is faster. But this one is time domain. So we are not, you are using a frequency domain, but we can run if you want. Okay. We can run it before and after compensations. Okay, so if there is no
Prof,
yeah,
I have question. Can we go to slide number 71?
71.
Okay, number 3 stated that additional correction factor might be needed, right? So how I'm supposed to know that if the system need the correction factor or not.
You just add 10 degrees. So for
Oh.
my class, section 5 and section 6, just add for if you want to answer lead or lag, just add 10 degrees correction factor.
Okay, Prof. Thank you.
So the last examples, okay. Example 6. Nur Aina, tolong baca.
For a unity feedback system with a forward transfer function, design a lead compensator for the system to yield 20% overshoot, RTS equal to 0.2 second, KV equal to 50.
So if we run this closed loop transfer function and find the time response 0.2. So this is before. Okay, design early. This one is after compensation 0.2. Now we don't know, okay, the value of K. So we have to design. This one is more or less like the previous examples. So this is the answer. Okay. So solutions, same as well, 20% overshoot. I think similar like just now. 48.2 degrees. Okay. And KV 50. So KV 50. Use this formula. KV 50. Okay. So K will be 300,000. Okay. So plot this 300,000. Plot. Okay. Natra, can you find omega PM?
Yes, Doctor.
Omega PM.
Uh, 40 radian per second.
Cepatnya. Okay. 40. See, Michin, what is the phase margin?
30. 30.
See. How you get 30?
Negative 150 minus 180.
Okay. So the solutions is shown here. Okay, either use the formula or use the bandwidth. Okay, so this is KV 300 and thousands. Okay, the bookload. So we don't have to find the gain margin because the only concern is on the phase margin. Okay, so don't worry about the gain margin. Okay, so similar to the previous examples. Okay, so dia macam sama je 48. Okay, macam tadi tu. Correction factor 30. But in this case dia tak add correction factor. Okay, kita add correction factor 58.1. Oh, dah masuk dah. Okay, 48.1 at 10 degrees, so C58 22.9, more or less the same like just now. The value saja, change the value saja. Okay, more or less you get the answers is 2.27 S plus 33.2 ZC and PC. Okay, so you use the graph that I gave. to find the solution, the suitable solutions. And this one, not included in the final exams. So you study until here. Slide 93. This one solution is quite long. Okay. The end. So lecture finish at here. After this, we will review back again the test question last week. Okay. And then Wednesday, maybe we discuss about final exams samples. Okay. And next week will be the presentation day. When is the last day of the class? Next Wednesday is the last day of the class. Guys,
Yes, Doctor.
last day of the class bila?
Next Wednesday.
Next Wednesday. So you have to do presentations after you submit your assignments on Friday, because I have to evaluate your soft skill. Okay. So we already complete gain adjustment, lag compensator and lead compensator. For the purpose of final exam, lag compensator is not included in the final exams. Okay, so we have a break about 10 minutes. Okay, Ken? Guys, 10 minutes break.
Can, Doctor.
All right.